Hello guys, I'm Muhammad Aslam Abbas from SRMDR Engineering College, and my teammates are Navanishwar, Tamilarasan, and Fleegan Breezer. We had done a project in IoT based irrigation system, and I would like to thank Smart Interns for giving us an wonderful opportunity and a knowledge about the IBM cloud. Our project is IoT based smart farming irrigation system. Before explaining the project, I would like to explain the explain the steps that we have done, and my friend will explain about it.
Since it is a IoT based project, it do require a cloud for sending the data, storing the data and to manipulate the data. No red flow was used for building the UI. It is very much easier for beginner to create a UI with the help of this software. Since it was a virtual intent, I used IBM sensor simulator for sending the data to the cloud. According to me, very interesting part of the project will be getting the weather station data from the Open Weather API. Final and the most important part will be controlling the devices like light, motor, etc. with the help of web application, and these data of this device will be seen in the Python script. I would like to share the step-by-step procedure required for completing the project. First step of our project is logging into the IBM account using your email ID. Signing up of our IBM cloud require an email ID. We can use normal email ID to sign up our IBM account in the cloud. In case of institutional email ID, we will be given with more feature in the IBM cloud. So we could see two devices. One among the devices were and another one is not connected. So after creating the account, the next step will be installing the IBM IoT platform. In this video, I will not be explaining the procedure for creating the IBM IoT platform, so please don't worry about it. I had given my GitHub link below the description of this video. So I had given the step-by-step procedure for creating the IBM account and installing the IBM IoT platform in a PDF format. So next step will be creating two unique devices and one mandatory API key. These two things are very much important for proper node creation. Our next step will be setting up the IoT sensor. I will show you the display of IoT simulator. It requires data like organization ID, device type, device ID and device token. If we give those data to them, it will start to generate some random values, and these values will be sent to the cloud. Developing the UI is the most important and the crucial part in IoT based smart agriculture system. So our web application will be consisting of three tabs. First one will be home page. Second one will be sensor simulator data, which will be displaying the simulated data from the IoT simulator. The third part will be displaying the weather station data attained through weather API. First home page will be consisting of a template. The template will be consisting of a code written in HTML format. It will have a background image for the pleasant appearance. Second node will be consisting of the IBM IoT node as well as IBM IoT in node as well as IBM IoT out node. These two will be very much important in this project. These two nodes will play a vital role in getting the data as well as transferring the data to the Python scripts. So the major difference between the IBM IoT in node and the IBM IoT out node is, if the node is present at the exit at the right hand side of the box, then it will be set to be as IBM IoT in node. If the node is present at the left hand side of the box, then it will be termed as IBM IoT out node. IBM IoT out node will be used for controlling the loads. IBM IoT in nodes will be getting the play a vital role in getting the values from the sensor. So I had used a simple function for parsing the payload values. The payload values will be in the combination of temperature and humidity. So I had passed the separated the temperature and humidity value by using the function. I had given gauge as well as a chart for displaying those datas. And the second part will be consisting of IBM IoT out node. I linked it with two buttons for switching on and off the light, and it will connected to the status text box. It is used to show the status of the light, whether it is on or in off condition. And the third part of the tab will be dealing with the displaying the data from weather stations. The various parameters like wind speed, temperature, humidity, and type of weather system can be parsed from the API. The one of the most crucial thing we need to keep in mind is while parsing a API, we need to trigger it for a certain interval of time. But in Open Weather API, they had given a exemption that we can able to trigger a data up to 16 triggers per minute, it seems. So after triggering those data, a set of JSON value will be coming. We need to parse those JSON values. While the parsing of the data JSON is done by switch change node. So I will be opening those change nodes. Here we can see that the payloads had been parsed with the help of this change node. For displaying those parameters, I had used a gauge as well as a chart for displaying those parameters. This one is used for displaying the status of the weather. Each weather has unique icons for representing it. So in order to classify it, I had used a separate function. I had given in the code in the description. So now we will be seeing the UI. As I said earlier, our UI will be composed of three things. First one is a home page. It will only consist of only background and a title. Second one is sensor simulator data. It will be displaying the data coming from the IoT simulator, and the charts will be showing the data of it. And it also comprised of light on and off switch. So third tab will be consisting of it will display the parameters like temperature, humidity, wind speed in the form of gauge as well as in chart. We could see it. So we could also see the image. So as I said earlier, each weather has its unique icons. These icons can be displayed by using this function nodes. Final part of the video will be dealing with sending the data to the Python script. As soon as I press the light on button, there will be a change in the status. As soon as I press the light off button, there will be a change in the status. Like it will be turned to turn off light. So once again I will make a try. We could see the change. So I had used Anaconda for getting the values from the IBM. I had also provided the Python file in the GitHub repository for getting the data from the IBM. So we could at the end we could see this. We could get the update that the light had been turned on. So if I click light off, you could see the command that it had been turned off the light. Once again we will make a try. We could see that the status, and there is an update in the Python script. It is showing that the light had been turned on. Thank you guys for listening in video. I hope you guys would have gained something from this video.